It looked as if it's 20 kilometers, which is huge. It's as big as Manhattan Island.
3I/ATLAS is giving scientists headaches, and it might not even be natural. 3I/ATLAS, a mysterious visitor from beyond our solar system, has been keeping astronomers on their toes. Its trajectory, composition, and now its slowing speed are raising questions that challenge everything we thought we knew about comets. In this video, we break down what makes this interstellar object so strange and why some experts are considering radical possibilities. Follow along as we uncover the strange behavior of 3I/ATLAS. Subscribe and turn on notifications to stay updated on this cosmic mystery. The discovery that changed everything. It's July 2025, and astronomers in Chile are scanning the night sky with the Atlas telescope, doing what they do every single night. Nothing unusual, just routine observations. Then suddenly their screens light up with something that makes them do a double take. They've spotted an object moving through space, but this isn't just any space rock passing by. The team quickly realizes they're looking at something extraordinary. This object isn't bound by our sun's gravity. It's traveling through our solar system from somewhere else entirely, somewhere between the stars. They name it 3I/ATLAS, the third confirmed interstellar object ever detected by humanity. The first was the mysterious Oumuamua back in 2017, followed by Comet Borisov in 2019. But here's where things get fascinating. From the very first observations, 3I/ATLAS starts showing characteristics that don't quite add up. It's moving on a path that brings it surprisingly close to several planets in our solar system. The astronomers plot its trajectory and realize this visitor is heading toward the inner regions, scheduled to make its closest approach to the Sun on October 30th, 2025. What makes this discovery even more thrilling is the timing. We're catching this object relatively early in its journey through our cosmic neighborhood. That means telescopes around the world have months to study it, to gather data, to try and understand what exactly we're dealing with. Observatories from every continent start pointing their instruments at this mysterious traveler. The initial excitement in the scientific community is palpable. Every interstellar object we've detected has taught us something new about the universe beyond our solar system. But nobody knows yet that 3I/ATLAS is about to become the most puzzling visitor we've ever encountered. The real mysteries are just beginning to unfold. The expected behavior of comets. To understand why 3I/ATLAS is causing such a stir, we need to talk about how normal comets behave. When a typical comet approaches the Sun, it follows a predictable script that astronomers have observed thousands of times. It's like a cosmic dance choreographed by the laws of physics. As a comet gets closer to the Sun, the ice on its surface starts heating up. This frozen material, made up of water, carbon dioxide, and other volatile compounds, begins to vaporize. This process is called outgassing, and it's what gives comets their spectacular tails. The evaporating material shoots off the surface, creating those beautiful streams of gas and dust that can stretch for millions of kilometers. Here's the crucial part. When material blasts off a comet's surface, it doesn't just disappear. According to Newton's third law, every action has an equal and opposite reaction. So when gas and dust shoot away from the comet, they push the comet itself in the opposite direction. This creates what scientists call non-gravitational acceleration. Think of it like a rocket engine, but instead of burning fuel, the comet is losing ice. This rocket effect causes the comet to deviate slightly from the path that gravity alone would dictate. Astronomers can measure these deviations with incredible precision, and they use them to calculate important properties of the comet, like how much mass it's losing and how big it actually is. For decades, this understanding has worked perfectly. Scientists can predict a comet's path, account for the non-gravitational acceleration from outgassing, and their calculations match observations beautifully. It's one of those areas of astronomy where the science feels settled, where the equations work exactly as they should. Until 3I/ATLAS came along and decided to rewrite the playbook. The anomaly nobody saw coming. Now we get to the part that has everyone scratching their heads. When astronomers started tracking 3I/ATLAS with extreme precision, using observations from 227 different observatories around the world, they noticed something absolutely bizarre. Or, more accurately, they noticed the absence of something they absolutely expected to see. Between May and September 2025, scientists gathered 4,022 individual measurements of 3I/ATLAS's position. They were looking for those telltale signs of non-gravitational acceleration, the little pushes and nudges that outgassing should create. They had the equipment, they had the time, they had the perfect opportunity to measure these effects. But the measurements showed something shocking. The non-gravitational acceleration was incredibly small. In fact, it was so tiny that scientists could only establish an upper limit of 15 meters per day squared. To put that in perspective, this is far less than what they should be seeing from an object that's actively outgassing. Here's where it gets really weird. The James Webb Space Telescope observed 3I/ATLAS in August 2025 and confirmed that it is releasing material. The comet was shedding about 150 kilograms of material every single second, with gases shooting away at speeds of 440 meters per second. That's a serious outgassing activity. By all rights, this should be pushing the comet around noticeably. So we have a paradox on our hands. 3I/ATLAS is acting like a comet, showing all the visual signs of outgassing activity, creating a visible coma and even developing tails. But it's not moving like a comet should move when it's losing all that material. It's as if the rocket effect simply isn't there, or it's being overpowered by something else entirely. This isn't just unusual. According to everything we know about comet physics, it shouldn't be possible. The mass calculation that shocked scientists. When faced with this apparent impossibility, a team of scientists led by researchers, including the well-known Harvard astronomer Avi Loeb, decided to work backward from the data. If 3I/ATLAS isn't being pushed around by its own outgassing, there has to be a reason. And the most straightforward explanation is absolutely mind-blowing. The math is actually pretty simple, even if the implications aren't. When material shoots off a comet's surface, it exerts a force. That force creates acceleration, which depends on the comet's mass. The bigger the mass, the smaller the acceleration for the same amount of outgassing. It's basic physics, but when you plug in the numbers for 3I/ATLAS, something incredible emerges. Given the observed outgassing rate from Webb telescope data and the mysteriously low non-gravitational acceleration, the scientists calculated that 3I/ATLAS must have a minimum mass of 33 billion tons. Yes, you heard that right. 33 billion tons. That's an absolutely staggering number for a comet. To put this in perspective, the other interstellar comet we've studied, 2I/Borisov, was estimated to be thousands to millions of times less massive. Even accounting for uncertainties in the measurements, 3I/ATLAS appears to be in a completely different league. If this mass estimate holds up, we're talking about an object that's 3 to 5 orders of magnitude more massive than the other interstellar visitors we've detected. At solid density, this mass translates to a nucleus diameter of at least 5 kilometers. That's huge for an interstellar object. The Hubble Space Telescope's observations suggested a size range between 0.44 and 5.6 kilometers. So this calculation puts 3I/ATLAS right at the upper end of that estimate. We're potentially looking at one of the largest interstellar objects ever detected crossing through our solar system. The statistical nightmare. Here's where the story takes an even more troubling turn for astronomers trying to explain 3I/ATLAS. Naturally, the mass calculation doesn't just raise eyebrows, it creates a serious problem with the statistics of interstellar objects. Think about it this way: rocky material gets ejected from planetary systems all the time throughout the galaxy. Collisions, gravitational interactions, all sorts of cosmic violence sends debris flying into interstellar space. Over billions of years, this creates a vast reservoir of wandering objects between the stars. But here's the catch: there's only so much rocky material to go around. The heavier elements needed to make these objects aren't infinitely abundant in the universe. So when scientists calculate how many interstellar objects of different sizes should be floating around, they get a pyramid-shaped distribution, lots of small stuff, fewer medium-sized pieces, and very rare large objects. Based on these calculations, if 3I/ATLAS really is as massive as the data suggests, we should have detected roughly 100,000 smaller interstellar objects before finding something this big, but we haven't. We've only found 2 other confirmed interstellar visitors before 3I/ATLAS, Oumuamua and Borisov. The odds don't add up. It's like winning the lottery 3 times in a row. Sure, it's technically possible, but it strains credibility. Either we've been extraordinarily lucky, or something about our understanding is fundamentally wrong. Maybe the interstellar mass reservoir is different than we think. Maybe detection methods favor certain types of objects. Or maybe, just maybe, 3I/ATLAS isn't a natural object at all. This statistical anomaly is what's keeping scientists up at night. It's not just one weird measurement. It's a web of observations that don't fit together neatly into the natural comet hypothesis. The trajectory that raises eyebrows. 3. I/ATLAS's trajectory through the solar system is drawing attention because it is unusually aligned with the ecliptic plane, the flat disk where most planets orbit the Sun. While natural interstellar objects can approach from virtually any angle, the odds of one coincidentally matching the ecliptic so closely are roughly 1 in 500. This alignment alone is curious, but it becomes even more intriguing, considering the comet's path brings it relatively close to several major planets, including a flyby of Mars in October 2025 and an upcoming approach near Jupiter in March 2026. Some researchers have noted that such a trajectory resembles an efficient observational path, almost as if designed to study multiple planets up close. While coincidences do occur in space, the combination of this unusual orbital alignment with 3I/ATLAS's other anomalies, its mass, composition, polarization, and activity, adds another layer of mystery. Each detail reinforces that this interstellar visitor is far from ordinary, leaving scientists to question whether we are seeing a simple natural object or something far more complex. The color changes nobody expected. During the summer of 2025, astronomers tracking 3I/ATLAS observed a notable change in the comet's coma, which became progressively redder through July. While color shifts in comets can occur naturally as different materials vaporize when heated by the sun, the reddening of 3I/ATLAS suggested active changes in the surface composition or the materials being released, reflecting real-time evolution in its activity. Scientists documented this trend, highlighting that the comet's behavior was more dynamic than typical solar system comets. In September 2025, a green glow also appeared around 3I/ATLAS, likely caused by carbon molecules fluorescing in sunlight. What made this unusual is that earlier spectroscopic studies hadn't detected significant carbon, implying that either initial observations missed something or that new materials were being released as the comet approached the Sun. These color variations indicate a layered, evolving surface and emphasize the complexity and unpredictability of 3I/ATLAS, adding yet another layer to its growing list of anomalies. The Hubble images that revealed something strange. In July 2025, the Hubble Space Telescope provided the clearest view yet of 3I/ATLAS, revealing both familiar and unusual cometary features. High-resolution images captured an anti-tail pointing toward the Sun, optically thin and persistent for weeks, which, while known in comet studies, was unusually prominent in this case. These observations offered insights into the distribution of dust around the nucleus, showing that despite complex tail structures, the brightest point consistently remained at the nucleus, helping reduce uncertainties in trajectory measurements. Later observations from the Gemini South Telescope documented the growth of a more conventional tail extending away from the Sun, indicating that the comet's activity was evolving as it approached perihelion. Combined with Hubble data, astronomers estimated the nucleus size to be between 0.44 and 5.6 kilometers, which, when considered alongside mass calculations from trajectory analysis, confirms that 3I/ATLAS is a remarkably large and massive interstellar object, adding yet another layer to its growing list of anomalies. The chemical composition mystery. Spectroscopic analysis of 3I/ATLAS has revealed a puzzling chemical anomaly. Observations from the Very Large Telescope and other facilities detected nickel in the comet's coma, but no accompanying iron, which is highly unusual for natural cosmic objects. In typical asteroids and comets, nickel and iron are found together, forming in stellar processes and sticking together over time. The absence of iron in 3I/ATLAS challenges conventional expectations and suggests a composition unlike anything seen in the solar system. While it's important to remain cautious, limitations in Earth-based spectroscopy, viewing angles, or the comet's activity could mask the presence of iron, the nickel-only signature is nonetheless striking. Interestingly, nickel without iron is common in industrially manufactured alloys, though this doesn't prove artificial origin. Combined with other anomalies, this chemical peculiarity adds another layer to 3I/ATLAS's growing list of mysteries, prompting scientists to question whether current interpretations of its nature are missing something fundamental about this interstellar visitor. What the Webb telescope revealed. The James Webb Space Telescope, humanity's most advanced space observatory, added its own critical piece to the 3I/ATLAS puzzle in August 2025. With its incredible sensitivity to infrared light, Webb could detect heat and molecules that other telescopes might miss. Webb's observations confirmed active outgassing from 3I/ATLAS. The telescope measured the mass loss rate at approximately 150 kilograms per second. To give you a sense of scale, that's like losing a grand piano worth of material every 2 seconds. This is substantial activity for a comet at this distance from the Sun. The telescope also measured the speed at which this material was leaving the nucleus, roughly 440 meters per second, or about 1,600 kilometers per hour. This outflow velocity tells us about the energy involved in the vaporization process and the forces acting on the released material. These Webb observations are absolutely crucial because they provide ground truth for the mass calculations we discussed earlier. When scientists know exactly how much material is being ejected and how fast it's moving, they can calculate the momentum being carried away from the comet. This, in turn, should tell them how much the comet itself should be pushed around by this rocket effect. And that's precisely why the Webb data makes the anomaly even more striking. With confirmed measured outgassing at these rates and velocities, there should be a clear non-gravitational acceleration. The fact that this acceleration is essentially undetectable means the comet must be far more massive than its observed activity would suggest. Webb also provided insights into the thermal properties and composition of the gas being released. This data helps scientists understand what ices are present on the surface and how they're responding to solar heating. Every observation adds detail to our picture of 3I/ATLAS, but somehow each new detail makes the overall picture stranger rather than clearer. The polarization puzzle. One of the lesser-known but equally intriguing aspects of 3I/ATLAS is its unusual polarization. When light interacts with a comet's dust particles, it becomes polarized, revealing clues about particle size, shape, and composition. Over decades of studying comets, astronomers have developed expectations for these patterns, but 3I/ATLAS does not conform to them. Observations published in September 2025 revealed extreme negative polarization, a signature unlike anything seen in typical solar system comets, suggesting its dust has unique optical properties. This anomaly could indicate dust grains with a different composition, perhaps formed in a distant part of the galaxy, or surfaces altered by prolonged exposure to interstellar radiation. Like many other measurements of 3I/ATLAS, the polarization data challenges conventional explanations and adds to the growing list of characteristics that don't fit the natural comet model. Each piece of data deepens the mystery, forcing scientists to rethink assumptions about what kind of object they are observing. The close encounters with planets. On October 3rd, 2025, 3I/ATLAS made a close approach to Mars, providing a rare opportunity for detailed observation. The Mars Reconnaissance Orbiter's high-rise camera captured images of the comet from a unique vantage point, allowing scientists to better estimate its nuclear size and reflectivity. Observing the comet from Mars offered insights impossible to obtain from Earth, complementing the data collected by ground-based telescopes and adding new depth to our understanding of its physical properties. The story doesn't end there. In March 2026, 3I/ATLAS will pass near Jupiter, where NASA's Juno spacecraft could conduct another round of close-up observations. Scientists, including Avi Loeb, have proposed using Juno to gather dedicated data during this encounter, with some political and scientific support for the plan. These planetary flybys are not only scientifically valuable, but also intriguing, given the comet's trajectory, which seems to offer multiple chances for observation, a detail that some see as curious, though it may be purely coincidental. The hypothesis. Nobody wants to say out loud. With the growing list of anomalies, some researchers have cautiously entertained a provocative hypothesis. What if 3I/ATLAS isn't natural at all? While entirely speculative, this line of thinking is a legitimate exercise in science, considering all possibilities when data defies conventional explanations. A July 2025 paper explored the implications of a technological origin, including the possibility of a probe or artificial object navigating our solar system for observation purposes. Such a hypothesis could account for several strange features: an unexpectedly high mass, unusual chemical composition like nickel without iron, and surface volatiles that might serve both camouflage and thermal regulation purposes. Its trajectory, passing near multiple planets, aligns with what one might expect of a designed observational path. However, this remains theoretical. Extraordinary claims demand extraordinary evidence, and while the technological hypothesis provides a potential explanation, it is far from confirmed. 3I/ATLAS is an interstellar visitor that defies expectations, displaying comet-like characteristics yet moving unpredictably, with unusual mass, trajectory, and chemical composition that challenge conventional understanding. Whether it's an extraordinarily strange natural object or something entirely unprecedented remains unknown, but the anomalies are real and documented. Regardless of the explanation, 3I/ATLAS has already sparked curiosity, forcing scientists and all of us to question assumptions and take a closer look at our cosmic neighborhood. What do you think? Is 3I/ATLAS just an unusually massive comet with weird properties? Or do these anomalies point to something more extraordinary? Drop your thoughts in the comments below.